Class, today our video is going to be from section 1.1, solving linear equations and formulas. Now, before we jump into the notes part on this, just a couple of quick comments. Um, our first unit test is over the review chapter and chapter one. I feel like, with the review chapter, that's like theoretically like high school stuff that you're supposed to know, and we don't have time to fully teach it. And it's more like the Algebra 2, intermediate algebra level stuff. And it's skill sets that are going to pop up randomly throughout the semester. But it's really not college algebra level material. Um, it's why it's in the review chapter. Um, Chapter one to me is where we're starting to get into the like official college algebra stuff. It's still kind of, I guess, college algebra light, and it's to me it's still stuff that it's reviewing, but I think sort of the difference between the review chapter and chapter one, the themes that we talk about in chapter one definitely get used all semester. The review chapter, it's more a little bit more here and there sort of algebra skill sort of stuff. So it's important content, but it's not used, I guess, as widely as the chapter one material. But like I said, it's all still review. It's all good stuff to go over. But to like today's topic with the solving linear equations, I don't have time to do the really basic equations. And so one thing I do want to point out, for those of you that want a little bit extra review, maybe you've been out for a little while, is let me show you something where I store my videos. So me and another instructor, Ms. Dampier, who teaches a lot of online classes, we store our videos on YouTube. I'm not a big YouTube person. I know the bare basics, but we the school doesn't have like the cloud storage for us to store stuff in the cloud. So almost all of us store our videos to YouTube before we send them to you. And together we share a channel. And so for those of you that are looking for a more basic review on the linear equations, um, the channel that we use is CAS Mathematics, CACS Mathematics. And if you're looking for some basic review, the 1413, the survey class, has some of the material. So if you go to the playlist, look for 1413 Unit 1. Oh, I don't want that particular video. So class, I've had, sorry. As you can tell, I'm all right. So what you're looking for is, well, I mean, the 1413, the survey class, we go all the way to rounding estimation, negative numbers, order of operations. But for those of you, like, especially for today's topic, we're getting into relatively messy linear equations. And so the really basic equations is right there. And we have multi-step equations. That's sort of, we're kind of starting at the high end of where this class leaves off. And there's more practice with formulas. And so as you're going through, particularly the 1.1 homework, if you find or feel that you need to back up and do some more basic stuff, I would recommend going into my YouTube channel, which is CAS Mathematics, and look for 1413 Unit 1. And then you can find some equations that, like I said, kind of warm up to what we're doing today. Okay. All right. So let's get into our actual content. So as always, I am pulling this from Blackboard lecture notes. And so what we're doing in Blackboard is, let me open that up. So solving linear equations and formulas. So let's jump into it. All right, now the study guide is not greatly detailed on the when I say solve various linear equations, um, it's a lot of what I would think of sort of relatively messy equations. at the college algebra level. And so we're going to deal with equations, definitely have variables on both sides. There's going to be some distribution, some combining like terms to deal with. We're going to get into equations with fractions, which I know everybody loves. And we're going to also be dealing with some proportions. So those are like that's the variety of equations we're going to be dealing with today. And then we're going to get into formulas. Formula stuff is something that we don't necessarily use a lot in college algebra, but especially for those who go into chemistry, you're going to be dealing with formulas all the time. And then that's a skill that's related to equation solving that everybody needs to get out of the class. The other thing is in a college algebra and like any algebra course, one of the themes is being able to solve equations. And so the most basic equation we have to solve is a linear equation. That's why we're starting here. Next couple of videos, we'll be talking about solving quadratic equations. And then as we progress throughout the semester, we're going to talk about more and more types of equations to solve. And so one of the things you have to be able as a student is, one, recognize what type of equation that you're dealing with, and two, know the general process. So as we're going through this, particularly next week when we get into the quadratic equations, like knowing when to what your goal is important. So when we're solving linear equations, our general goal is to get x equals a number, or y equals a number, or whatever the variable is. Right? And we do that in general by isolating the variable. I move in the variable to one side, everything else over to the other. And that's different than our approach to, say, quadratic equations, where you have to set it equal to 0 and then start doing other techniques. Right? So being able to recognize linear equation, know the general process is definitely important. So there's a lot going on in that one little statement there of solve various linear equations. All right, so let's jump into the notes and get going. All right, let's see. So I'm going to skip 1 and 2. Like I said, those are kind of warm up. Let's start with number 3. This is like a core equation that you should be able to solve with college algebra. All right, so for solving this, so remember, in general, our goal, anytime it says solve, our goal is we want x equals a number. Now, for linear equations, typically there's going to be one solution. As we get into quadratic equations, like with x squared, there's going to be 2 solutions. If we do x cubed or x to the 4th, there could be 3 or 4 solutions. But in general, for linear equations, there is a single, number that's an answer. Now, if you took 1413, the survey class last semester, that's what, we dealt with those kind of equations. There are one of the types of equations we didn't deal with in that class that you may see occasionally here is we do have special case equations where either sometimes there's no solution or there's infinite solutions. So just because we're solving an equation doesn't necessarily mean there's only one answer or one number answer. There could be special cases, and then as we get to other types of equations, it could have more answers. But just big picture, what we're trying to do today, try to get x equals in a nutshell. So when you have something like this, x minus 12 equals 3x minus 20, how do you solve it? How do you get x by itself? Well, first thing is, treat that equal sign sort of like a grouping symbol in order of operations. You have the left-hand side and the right-hand side of the equation. One thing you should always do before you actually start the solving process is ask yourself, is there anything on the left that can be done? Which basically means, is there any distribution or combining like terms? And same on the right side. Is there any distribution or combining like terms that you can do? Where possible, you always want to simplify your equations before you start the solving process. Those are unlike terms, no distribution, so we're ready to start solving. One thing I would point out, if you look at the x and 3x and think those are like terms, technically they are, but I don't like to call them that because they're on opposite sides of the equal sign. Because there's a big difference between if they were on the same side versus on a different side. Because if it's on the same side, like if it was x plus 3x over here on the left, then you would just combine those and say, x plus 3x is 4x. Straightforward. However, if they're on opposite sides, you cannot abstract terms across the equal sign. So I can't say x plus 3x is 4x. And like, even if you did, like, which side would you put it on? Right? So one of the core idea when you're solving linear equations is that when you're moving terms across an equal sign, whether they're constants or variables or coefficients, you're always doing the opposite operation. But the only time you do opposite operations if you're moving across an equal sign. If you're doing something on the same side of an equal sign, do not do the opposite. Just do what the math says, and we'll do some examples of that. All right. When you have variables on both sides, you have to make a decision which side do you want the variable on. Sometimes students skip this step and they just start manipulating stuff, and that may get you for the smaller equations, but for bigger equations, I always kind of like to have a goal. In the long run, it does not matter which side you get your variable to. The most common is to get it to the left. That way we have x equals a number, but you could have a number equals x. When we get into the inequalities at the end of this chapter, I will talk about it's probably better to put it on the left just because of the graphing that comes along with inequalities. I personally like to move my variable so that I don't have a negative coefficient. But if you're comfortable getting the variable on the left every single time, then to do that. Okay. So what we're going to do here is I'm going to get x on the left. So how do we do that? Well, the reason that I want you to make this conscious decision is what's going to have to move in this equation. Well, this x is good because it's on the left. That minus 12, that needs to get moved to the other side. That 3x, well, that's on the wrong side of the equation, so it needs to get moved over. Now that minus 20, that's on the right, so we want the numbers on the right, so that minus 20 is not going to have to move. So we're going to do something with that minus 12, and we're going to do something with the 3. Now, I know many of you have been taught to move your numbers first. There is the special case equations that I mentioned. When those pop up, if you're in the habit of moving your variables first, in the long run, that's better. So let's deal, well, for this first one, let's do the number first, and then the other examples, I'll move the variables first. Here's the question. How do you get the minus 12 over to the right-hand side? Well, this is where we use opposite operations. So what's the opposite of subtracting 12? That's adding 12. And so what you do to one side, you have to do to the other because we have to keep the equation balanced. And so minus 12 plus 12 goes to 0, which is what we want. So on that left-hand side, we're left with just x. Don't lose your equal sign, particularly for people who are rusty. A lot of times that kind of disappears and gets lost. You always need two sides of an equal sign. Over here on the right, we got 3x, and then minus 20 plus 12, it goes to minus 8. Okay, so now we need to move 3x over to the left. And so how do you do that? At this point, do I have a pencil? I have a pencil, so I don't know if I want to write it, so I'll just talk through. It's not unusual for me to see people want to divide by 3. Because you're used to, there's a number for the x, so let's divide because that is 3 times x. So the opposite of multiplying by 3 is dividing by 3. But here's the problem if we divide by 3 at this point. First of all, what are you supposed to divide by 3? Well, if you divide, you're supposed to divide every single term by that number. So we're not just dividing the 3x by 3 and the x by 3, also dividing the negative 8 by 3. And if you look at that, we're putting in fractions if we're doing that. I love fractions, but when it comes to equation solving, I like to use fractions as possible. So for the most of what we're doing, if you're dividing as part of your solving process, that should pretty much be the very last step. The other thing is, if we divide this by 3, well, 3x divided by 3 is x. That x is still on the right-hand side. So we didn't move it over. We just basically dealt with the coefficient. So dividing and multiplying only changes the coefficients. It does not move terms across. If you want to move terms across an equal sign, the entire term, not just the coefficient, that's when you use add or subtract. So to deal with this 3x, well, that's a positive 3x. So to move it to the other side, we're going to have to subtract 3x. And if we subtract 3x from one side, we've got to subtract 3x from the other side. All right, so a couple of things here. One, what is 3x minus 3x? Hopefully you're saying 0. If you're saying x, that's the reason I asked this question. If you're saying x, you're really saying that there's one x left. And 3 minus 3 is 0. 0x, 0 times anything is 0. So the whole reason we're doing that is to zero it out on this side. The other thing is on this, if you mean subtract, please put your subtract. If you mean add, please put your add. All right, so that way, because a lot of times I see students do it correctly on the side they start with, and then they come over here, they just put 3x, and then they get it wrong because they end up adding instead of subtracting. So make sure that whatever operation you're doing, you make it clear. So now 1x minus 3x is 2x, actually negative 2x. Negative signs are a very big source of mistake when it comes to solving equations. And so over here, we have negative 8. So now we're getting close, because now we've got our variable on one side, most of our numbers on the other, but now we're going to deal with the negative 2. Okay. So how do we get the negative 2 to the right-hand side? Well, if you say plus 2, you're thinking, if it was x minus 2 equals something, then we would be doing plus 2 to zero it out. The reason we're doing plus 2 because opposite of subtraction is addition. Yeah. But we're not doing negative, x minus 2. What's the operation that connects those two? It's multiplication. So if you're a bit rusty on this, you may want to put that multiplication dot there to remind yourself that it's a multiply problem. So we're doing negative 2 times x. What's the opposite of multiplying by negative 2? Well, so multiplying is dividing. Now, do we divide by positive 2 or a negative 2? I get this is another common mistake is students tend to want to change the sign because up here, when you're abstracting, you're changing the sign, but that's because, what's the opposite of adding? Is subtraction and vice versa. So you have to change the sign there to get the opposite operation. But if you're multiplying by negative 2, the opposite of multiplying by negative 2 is dividing. So we're going to divide both sides by negative 2. So when you're doing this division, the last step, don't change the sign. Now, the reason we don't want to change the sign is negative divided by negative is a positive 1. And so you want a positive 1 in front of your x and not a negative 1. So then by both sides by negative 2, so it's 4. And then we don't need the 1 in front of the x, because 1 times x is x. We get an answer of x equals 4. And so like I said, this is where I mentioned that if you feel like this is a little bit too quick at the beginning, then if you get into the CASC mathematics YouTube channel, go to 1413 Unit 1 playlist. You're going to find basic equations, multi-step equations. So I'll kind of give you some warm up on this. And then how do we know that's the right answer? The nice thing about equations, you can always take that answer, plug it back in and check. So 4 minus 12 is negative 8. And then 3 times 4 is 12. 12 minus 20 is negative 8. So we get negative 8 equals negative 8. So that's the nice thing about those is you can check your answer. All right. Let's do number 5. 9 minus parentheses 4x minus 1 equals 2. What do we do with this? All right, this is where I talked about if there's anything you can do on one side of the equation, before you start solving, before you start isolating that variable, then you got to do it. All right, so on this left-hand side, there's definitely some stuff we can do. So if that's all you had, what would you do first? Well, we can't do anything with 4x minus 1. Those are unlike terms, but we can distribute that negative. And if it helps, you can make that a -1. Either way, it's going to change both those signs, right? Because when you're multiplying by a negative, or opposite of, you're changing the signs. So that's 9x, and then minus 4x, and then minus times minus would be a +1. Now what? Well, the most common mistake I see on this, especially early on, is students will look at this and want to add 4x because you're thinking opposite, right? Which, if that would be true if we're trying to move that minus 4x to the right-hand side. But we're not moving it across the equal sign. We're keeping it on the same side. So if you're doing the same side, do whatever the operation says. So you're just doing 9x minus 4x, which is 5x. So if it's on the same side, don't do opposite operations. Just distribute or combine like terms as normal. All right, now this one only has a variable on one side, so I'm going to keep the x on the left because that's where it is. Excuse me. So that means we need to do something with the 1 and the 5. And again, always do division last. The way I think of it, and since we're doing opposite operations to move terms across the equal sign, we're also going in opposite order of operations. So do your add subtract first. So in this case, we're going to subtract 1 from both sides. We get 5x equals 1. And now that's 5 times x. So we're going to divide both sides by 5. And again, don't change the sign. Now, a note from MyMathLab. MyMathLab is, if you put this as a decimal, MyMathLab will count it wrong. Typically, the only time we want our answers as decimals is if the equation starts with decimals. Otherwise, keep it as a whole number or a simplified fraction. And don't go to mixed numbers if you get one. Keep it as an improper fraction. Just make sure it's simplified, but we either want whole numbers or fractions. All right. Pretty typical problem. Again, the most common mistake here I would expect would be one, that people would not distribute the negative and they'd have a -1, or they would do plus 4x, like plus 4x and get 13x. But if you're doing that, you're really adding like 8x on this side and adding nothing over here. So then you're like unbalancing the equation. All right. Today is just a big example day. So let's look at number 6. So we got 6 parentheses x plus 7 equals 6x plus 42. So 6 parentheses x plus 7 equals 6x plus 42. So how are we going to solve this? What's the first step? Well, on that left-hand side, we have some distribution to do. So that's first. 6x plus 42 equals 6x plus 42. Yeah. Well, we got variables on both sides, so which side do you want the variable on? Most common is going to be the left. So that means that 42 has to get moved over. So here's why I don't recommend moving your variables first. It's for, or sorry, your constants first. It's for this particular example. So if you subtract 42 from this side, that goes to 0. We're going to subtract 42 over here. So we get 6x equals 6x. And the most common reaction I get from the students at this point is now what? Yeah, we're trying to get x by itself when we got that 6x on both sides. This very commonly trips people up. I see people start doing weird things like dividing by 6. But if you divide by 6 on this side, you divide by 6 on that side, and then you just get x equals x. I see people divide by x. Which if you divide by x on this side, you're dividing by x on this side. You should, with what we're doing, you should never be dividing by your variable, only your coefficients. Right, so this tends to trip people up at this point. So let's come back and redo this, and then I'll come back and explain what to do from there. So let's, what happens if we move the variable first? So if I want the variable on the left, that means the variable term on the right has to get moved over. And so what do I do with that plus 6x? Well, to get it to the other side, I subtract 6x. If I subtract 6x from one side, I subtract 6x from the other. Now 6x minus 6x is 0. 6x minus 6x is 0. And we get 42 equals 42. Now we kind of get back to the same spot of what equals, now what? I was thinking this works out. My example would work out better if that would have been like, if they would have been different. But we'll still get the idea. So if we're down to here, there is no x. And I remember our goal was to get x equals. Well, if we have no x, what does that mean? It doesn't mean the answer is 42. That doesn't say x is 42. It says 42 equals 42. Or here it says 6x equals 6x. So how do we reach that goal of x equals something? Well, this is where we have the special case. And so when you're solving linear equations, if your variables go away on both sides, which here I think it's a little bit clearer to see that they're going away, because up here, what you should have done at this point was subtract 6x from both sides. Same thing we did here. And then you get 0 equals 0. Which may not be any more helpful than 42 equals 42, but both of these, the variable has went away. So if the variable goes away on both sides, then it's either, your solution is either all real numbers or no solution. So if variables cancel, I said don't have these in the notes. So if you have a true statement, like here, 42 equals 42, 0 equals 0. That's true. What that means is we have infinite solutions. Or another way to say that is all real numbers. What that means is no matter what you plug in, it's always going to work. If you look at this stage, we have 6x plus 42 on this side, 6x plus 42 on this side. We're doing the exact same thing to the number on both sides. Doesn't matter what you plug in for x, it's always going to work. Now, if you have a false statement, that tells you that there is no solution. So for example, I start with something like x equals x plus 1. If I subtract x from both sides, we get 0 equals 1, which is definitely false. Right? And so I'm telling you, this is no solution. So you look at this, we'll come back to the original problem. Is there any number in existence that if you add 1 to it, you have the same number that you started with? No, because it's always going to be one number higher. So there is no solution to this. Whereas this, no matter what you plug in, is always going to have a solution. So that's the infinite solution, or all real numbers. But just be aware, since we're in college algebra now, you are occasionally going to see these types of equations. It's not always going to be x equals a number, and it could be something like this. But just kind of keep that in your radar in the back of your mind. All right, let's do one more. Like I said, we get into some messy equations, and you'll see this in the homework. So let's look at number 8. Work through that one. Let's just do it here. All right, so we have 6x minus 4 plus 7 parentheses x plus 1 equals negative 5x minus 7. Okay, so how do we start this? Well, on that left-hand side, we've got a distribution because we have that plus 7 times outside the parentheses. So we're going to distribute that plus 7 to both of those. We have 6x minus 4 plus 7x plus 7 equals negative 5x minus 7. Don't be surprised if there's a fair amount of problems that have you distributing negative, because we're also kind of testing your paying attention to detail skills is what I think of those negatives. All right, so now what do we do with this? Well, that left-hand side definitely has like terms we can combine. And remember, if you're on the same side, do not do opposite operations. Just do whatever the add and subtract tells you. So we have 6x plus 7x, which is 13x. And then you got negative 4 plus 7, which is plus 3. So no opposite operations, just add and subtract as indicated. Well, now this is like, no matter how messy these start, in the end, you're going to get back to something like this. You've got variables on both sides, coefficients on both sides. You're going to have to solve this type of equation over and over again. Let's get the variable to the left. So now if I want the variable on the left, that means I need to move the minus 5x over. Opposite of subtracting 5x is adding 5x. That's what makes that go to 0. And what we do to one side, we do the other. Make sure you're doing like terms with like terms. Don't add that 5x to the 3 because those are unlike terms. Now, in interest of time, since I'm running out of space on the paper, I'm going to go ahead and do 2 steps at once. So since I'm moving the x to the left, that means the 3 needs to get over to the other side. So I'm going to subtract 3 from both sides. Should have done this on the other paper. All right. And so that gives me 13 plus 5 is 18x. That was 0 equals negative 10. So now what do we do? 18 times x. So we're going to divide both sides by 18. That gives me 1x or x. Now here, if you put that as an answer, it will get kind of wrong. So anytime you have a fraction that's an answer, make sure that it's simplified. And if you're a little iffy on fractions, don't forget about these nice little friends that we have. And make sure you know how to do fractions on your calculator, especially, like I said, if you're a little rusty with them. The nice thing about this is if I put in 10/18, hit enter, it gives me 5/9. So the calculator won't simplify your fractions for you. But we're just dividing by 2. But if it gets messy, you're not sure if it's simplified, don't forget your calculator. Now I had negative 10 divided by 18. Negative divided by positive is a negative, so we tend to put that answer that negative out front. MyMathLab should accept it if it's on top. Technically, it wouldn't be wrong if it's at the bottom, as long as you just have one negative. All right. So those are some of our messier, just linear equations. Definitely, you're going to see some with this distribution, with distributing negatives, with combining like terms. So those are our what I would think of as my standard linear. Let's do some non-standard equations. How about number 9? So just a heads up, that is a proportion because we have a fraction equals a fraction. Right, so if you see that, and right off the bat, you've got your variables in the bottom, so that looks weird. So let's jump down to do we want to? No, we'll just do it from there. So if you look at number 10, talking about a proportion. So if you have a fraction equals a fraction, and no extra, like we can't have 2 fractions on one side, but if you just have a fraction equals a fraction, this is a proportion. And the first step to dealing with proportions is doing our cross product. Should have had these 2 reversed, I think. So let's see how we do a cross product with a messy. In the homework, you're probably gonna have like a smaller one, may not have a binomial, but you may just have something like 2x in the bottom. but this is still a proportion. When we say do the cross product, what is the cross product? Well, the cross product is we're multiplying the top of one equation by the bottom of the other equation, vice versa. Now, here's where you have to be careful because of the binomials, is please put those in parentheses. Because you have to multiply the entire term, like this one, the entire thing has to get multiplied by 6. And over here, this one, the entire term binomial has to get multiplied by 4. How does that work? Well, when you're doing a cross product for a proportion, it takes an equation that has two fractions and makes an equation without fractions. It doesn't matter which side's which. I'm used to doing this one first. So now we have 6 times 2x plus 5 equals 4 times 2x minus 3. So that's what the cross product does. Takes that equation without fractions or with fractions, gives us an equation without fractions. Then what do? Well, get those distributes done. 12x plus 30 equals 8x minus 12. And so we took something that looked pretty messy. We did a cross product, we did a distribution, and now it's back to that standard. We have variables on both sides, numbers on both sides, go from there. Now, if this was in class, I would ask if anybody would want to solve it, or I would just say and solve. Since we're doing this video-wise, I'm just going to go ahead and finish solving it. It never hurts to get an extra example, right? So I'm going to get my variables on the left. So I'm going to subtract 8x from both sides. 4x plus 30 equals, and don't lose those negatives. Subtract 30 from both sides. That will zero that out. 4x equals minus 42. And then that's 4 times x. The opposite of multiplying by 4 is dividing by 4. That gives me 1x, which is just x. And this is where I know the answer is going to be negative because negative divided by positive is negative. If you do 42 divided by 4, you get 8 decimal. And remember what I said, we don't want decimal answers unless the equation starts with decimals. So what do? Well, you need to simplify this as a fraction. So, but always start, see if it's a whole number first. But we now know that 4 doesn't go into 42. So we have to simplify it. Well, they're both even. So we divide by 2. Proper answer we're looking for there would be minus 21 halves. If on a test you gave me the decimal, I'd probably take a point off because you weren't following instructions. But as long as you gave me the right decimal, you clearly did most of the work. So that is a proportion. If it's a fraction equals a fraction. This is a messy proportion. You might see things like really basic ones of like, I don't know, x over 3 equals 10 over 21, just making stuff up. That's a much quicker proportion. So then you just have 21 times x equals 3 times 10. So then 21x equals 30. Divide both sides by 21. Can that be simplified? So 3 goes into both of those, that will be 10 sevenths. So that's sort of like a pre-college algebra proportion. The basic fraction equals a fraction. This is a more of a college algebra level proportion. Still fraction equals a fraction, but now you got those binomials to deal with. Okay, so proportions are a special case of linear equations where you have just one fraction equals one fraction. There are many other types of equations with fractions, which I know everybody loves. So let's look at a couple of those. So, number 11. Now, technically, we could call this a proportion, but let's do this in a slightly different way. Yeah, because that is technically that is negative 7x over 8, means the same thing. But let's do this without the proportion. So let's say that how do we solve this? Well, we're trying to get x by itself. So that's just negative 7/8 times x. So what's the opposite? How do we get x by itself? So can't we just divide both sides by negative 7/8? So this is what I'm going to call the sort of the messy way. Okay, so if we divide both sides by negative 7/8, well, negative 7/8 divided by negative 7/8 is still 1. Doesn't matter how messy the numbers are. If you divide something by itself, it's 1. That gives us x. But this is why I don't recommend doing this, because now what do you do over here? If you know, then great. But again, fractions are one of those things that don't get taught well. So often this will intimidate people. But let me show you the how to deal with this. So that's a divide by, right? So that's negative 2/9 divided by negative 7/8. What you can do is rewrite this. Instead of writing it vertically, write it horizontally, but take that fraction and make it the regular divide by symbol. So how does that help us? Well, now it's a little bit easier to see. We're doing a fraction divided by fraction. How do you divide fractions? You invert the second one and make it a multiply problem. So we got negative 2/9 times negative 8/7. And now you just multiply and simplify. Which, multiplying, we have negative times negative, so answer is positive. Is there anything that can simplify? I know some of you have been taught to multiply first, but if you simplify first, you're dealing with smaller numbers. 2 doesn't go into 9 or 7. 8 is, 3, 2 times 2 times 2. There is nothing that simplifies here. Okay, so since there's nothing that simplifies, you just multiply top to top, bottom with bottom. We get 16 over 63. And we don't have to check to see if it simplifies anymore because I checked here. If you're not for sure, go back to your calculator. 16 over 63. And notice it gives me 16 over 63 back. So if your calculator gives you the same fraction you started with, it's showing you that it is already simplified. So that's sort of the messy way. So is there a quicker way, less messy way to do this? This is what I call I'm not big on mnemonics, but I'm going to call this invert and multiply process. And the reason this works is how did we divide, once we divided both sides by negative 7/8, what did we have to do? We had to invert the negative 7/8 and then multiply. So one of the nice things about this being an equation is basically we can skip this part and go directly to here. And so when I say invert multiply, what I mean is instead of dividing by negative 7/8, I want to flip this. And again, don't change the sign. And so instead of dividing by negative 7/8, multiply by negative 8/7. But you do one side, you do the other. And the whole reason we're doing this, what happens over here? Well, negative divided by negative is positive. 8 divided by 8 is 1. 7 divided by 7 is 1. So we're still putting a 1 in front of our x, which is the whole reason we did that. Now over here, what are we doing? We're doing what we did for the last step. So this whole invert multiply basically lets us fast forward through that. We've already got this answer, so we know it's 16/63. So if you get down to that last step on your equation and you have a fraction times your variable, instead of dividing both sides of that fraction, just invert it, flip it, and then multiply by it to begin with. That'll save you some steps. But again, this only to do this. This is like the last step, right? We've got our equation worked all the way down till the variable's on one side. It's multiplied by a fraction. So that's when we do that. Don't do that if there's other fractions or things going on. which is what our next example shows. All right, so if you look at 12, we have 3/5 plus x over 4 equals 17/20. So this is not a proportion because on this side we've got the two fractions. Technically, we could add those and make that one big proportion, and then like that side would look something like this maybe. We could, but there's faster ways to do it. We also don't want to, that's basically 1/4 times x. We don't want to like invert multiply both sides by 4, because now there's multiple pieces going on. So if you have an equation that has three parts like this, three or more parts, this is what we have something called clear the denominator. And so when you clear the denominator, the very first step that we're going to do here is multiply every term, like every term, whether it's a fraction or not, by the LCD. And if we do this correctly, what that's going to do is it's going to get rid of the fractions for us and give us an equation with whole numbers. All right, how does this fit? We're looking at number 12. We have 3/5 plus x over 4 equals 17/20. So that 3/5 plus x over 4 is to me what makes this a little bit messier version. So this side is why I'm wanting to clear the denominator. So what is the least common denominator? Right, and look at the equation all at once, look at all the fractions. So if you look at that and you're thinking 1, because there's nothing that goes into 4 and 5, you're thinking greatest common factor, which is basically the opposite of the least common denominator. So I don't care so much what goes into them. I want to know what do they go into. When you're looking for the LCD, always start with your biggest number, because very often that's your LCD. If it's not, then we need multiples of that. So notice 5 goes into 20, 4 goes into 20, 20 goes into 20. So 20 is the smallest number, the least number that all of those numbers will divide into. So 20 is our LCD. So how does that help us? Okay. And so again, to clear the denominator, we're going to multiply every term by the LCD. Now, if you have something that's not a fraction, I would recommend putting it over 1, because everything has to get multiplied by the LCD. In this case, I'm going to multiply everything by 20 over 1. The whole reason we're doing this is it should simplify to having whole numbers. So on this first one, does 20 times 3/5? Well, 5 goes into 5 once, it goes into 24 times. So then we have 4 times 3, which is 12. Or if you want, you can do 20 times 3 is 60. 60 divided by 5 is 12. I like to simplify first. At some point, do simplification. Doesn't matter if you do it first or last, really. On this one, we have x over 4 times 20 over 1. So that's 20x over 4. Or 4 will go to 4 once, so it'll go to 25 times. And then x times 5 is 5x. And the nice thing about this one, since it has the LCD, 20 divided by 20 is 1, so we just have 17 over 1, which is 17. So that's the power of clearing the denominator, is it takes this equation, that had multiple fractions, and now we have an equation without fractions. So then it's much more straight. I don't know about you, but to me, this is much more straightforward to solve. Again, if this is in class, I'd probably skip this step, but let's go ahead and finish it video. So we have 5x equals 5. Divide both sides by 5. Get x equals 1. This answer could have been a fraction, could be, in this case, it's a whole number, it's somewhat random. Just remember that if you do get a fraction at the end, make sure it is simplified. Solve this. All right, so that is equations with fractions. All right. I want to do another one of these, but let's see. I think there's better examples in MyMathLab. I don't know if we get quite this messy in MyMathLab. I will say here, what's the LCD? Well, there's an x and an x, so here the LCD would be x. So you'd be multiplying everything by x over 1. I don't know if we do that in the homework, so that's why I want to skip this one. What's the LCD here? Well, 4 and an x, the LCD would be 4x. We'd be multiplying everything by 4x. Both of these to me, especially this one, this is more like a pre-calculus equation with fractions, whereas we're doing more gen ed college algebra. Let me pause the notes and let's get into MyMathLab and see if we can find a different example from MyMathLab. Very quick. So we are in 1.1. Yeah, this one's a little bit long. It's 25 questions because you need a lot of practice with formulas. A lot of people definitely need practice with the equations. So this is one where just based on past experience, since there's a variety of what we're doing, we need to make sure we have plenty of practice in here. However, this is for a lot of people, this isn't as messy as the factoring, but it's still an important skill. Let me see if I can find one with fractions. Okay, yeah. Here's a good one. All right, so this is my number 10 from the homework. 1.1 homework. Number 10, we're going to solve, what do we have? 1/3 x minus 9 equals 4/9 x. Yeah, this is a good example for us to go over. All right, so let me get back to the camera. Right, and your number 10, you're just gonna have some, different numbers, same basic setup. One thing I do want to point out, we could deal with the fractions as fractions. We've got variables on both sides, so like you could subtract 1/3 x from both sides and then deal with the fractions as fractions. But again, even me, I like fractions and I still try to avoid fractions in equations. So since there's multiple fractions here, let's clear the denominator. One thing I would definitely recommend doing is that 9 is a whole number, put it over 1. So because you're less likely to lose that as part of the process. So when you're looking for the LCD, we've got a 3, a 1, and a 9. Always check your biggest number. 3 goes into 9, 1 goes into 9, so 9 is our LCD. So that means we want to multiply everything by 9 over 1. Now this is a little tight, so I'm going to write again to spread it out. So I'm going to do 1/3 x times 9 over 1. Now, again, the reason that I wrote that 9 is 9 over 1, I see a lot of students that would not multiply that by the LCD because they're not seeing that as a fraction. Doesn't matter if it's a fraction or not, always multiply every single term by the LCD. But again, I think you put that over 1, it makes it less likely to forget that step. Then we got 4/9 x times 9 over 1. So now we can do some simplifying. We get 9x over 3, or 3 will go to 9 3 times. So that's 3x. And then minus 9 times 9 is minus 81 over 1, or just minus 81. And then the last one here, the 9's cancel, just leaving us with 4x. And just to clarify, like that 4/9 x, that does mean the same as 4x over 9. And the reason being is, think of it this way, if you put that x over 1 to make it a fraction, now you're multiplying top to top, bottom to bottom. So when you have that variable out front, it is the same as having it on the top. All right. So by clearing the denominator, we have now went to an equation with no fractions. Now, you could get the variable to the left, but on this one, since there's only one constant in the problem on the right, then why don't we just leave that on the right and get the variables to the left? So if we subtract 3x, that goes to 0. We have minus 181 equals 1x, which 1x is x. Or we just get minus 81 equals x. You could have subtracted the 4x over, and 3x minus 4x would have been minus 1x. Then you would have added the 81, and so then you would have had minus 1x equals 81. And then you would divide both sides by -1, which gets us right back to the same answer. That's what you do with equations that have multiple fractions. If it's not a proportion where you can do your cross product, if it's not one of the basic ones here where you can do the invert multiply, if there's if there's 3 or 4 fractions, clear the denominator, make your life a little bit simpler. Okay. That is equations with fractions, and that's linear equations in general. That's sort of like the first half of 1.1. The other half of 1.1 is dealing with formulas. Formulas are still equations. It's just formulas. They tend to have a lot more letters. Very often formulas have real world connections. They don't always. But we're gonna, if you're like this first one, P equals 2L plus 2W. If you don't recognize that, maybe because you haven't seen geometry in a while, that's the perimeter of a rectangle is twice the length plus twice the width. Number 16, that A equals 1/2, little parentheses, little b plus capital B times H. That's the area of a trapezoid, and if you're going on to chemistry, you're going to see this, what we refer to as the Pivnert equation. If you're converting Celsius and Fahrenheit, that's a common equation. Right, so very often these formulas have real world connections. You don't need to know those to be able to do these problems. Right? And for unit 1, there are no formulas like this that you have to have memorized. All the formulas are going to be the problem, and you're going to be manipulating. One type of formula that we're definitely going to see next unit is on something like this that has x's and y's. If I ask you, what's the formula for the slope for a line, or like what formula do you remember? The most common question or the most common answer I get is that y equals mx plus b. So you kind of get, so we need to be able to solve these for y equals. So that's another type of formula. All right. We'll come back to that. Now, when we're solving the formulas, right, so just a general hint, if you get stuck, my recommendation is try to pretend that whatever variable you're solving for is x and ask yourself, well, how would I solve that if it was x? The reason I say that is we are so much more used to solving for x than other letters. And so I think that kind of reverts it back to like a normal type problem. So try to pretend your variable is x. The other thing with variables is sometimes we're given numbers to plug in. So if that's the case, we know P, we know W, we don't know L, so you're only going to have one variable in the problem. Students tend to do better with those because you're only dealing with one variable at a time. However, if we don't give you values to plug in, then you're going to have to treat variables, we're solving for F or C, we're going to have to deal with that F as F. Up here we're solving for T, we're going to have to treat P, V, N, and R as we're going to have to, they're going to be in the problem, you have to deal with it. So that's sort of the difference is up front, are we just dealing with one variable because we have numbers plug in, or are we not dealing with numbers plug in, so we have to deal with multiple variables? The nice thing about this, though, is we're still dealing with linear equations. Okay, so that means the process is exactly the same of all that stuff we've talked about with 1.1. Now, I'm out of paper, so I'm going to pause right quick. I'll be right back. Probably still a little funny to pause the video because my pause is way longer than your pause on your side. As long as I remember to unpause the video. I've done that before. Did like an extra 30 minutes of video and none of it was there. So, okay. Let's start with the formulas that we're just actually dealing with one letter at a time. Let's look at 15. P equals 2L plus 2W. And evaluate to find the unknown quantity. And if the answer is not exact, round to the nearest. Now, as always with MyMathLab, make sure to read the instructions if you're getting a decimal answer on the rounding. But if it says rounding, then that means if we get an answer that's a fraction, then don't stop as a fraction. Actually, we put it in decimal. The formulas were a little bit more common to use decimals. Just watch the instructions. It tells P is 28, W is 9. Now, the information we give you can kind of change the complexity of the problem. Here we're given P, we're given W, we don't know L. This would be a very straightforward problem if we gave you L and W and you're trying to solve for P, because then you wouldn't even have to solve. You just plug it into order of operations. Right? But since we're trying to solve for L, to all this stuff, this is why this is in the solving linear equations section. So first thing we do, plug in what we know. So P is 28. We don't know L. So it's 2L, and then W is 9, so we have 2 times 9. So what do we do first? Well, just like we talked about with the equations, if you have something to do on one side or the other, like simplifying, distributing, do that first before you start solving. You can do 2 times 9, 28 equals 2L plus 18. And now we have one variable that we're solving for, so we're solving for L. If it helps, think of this as X. How would you solve this if this was X? Well, hopefully you say and remove, subtract the 18 and then divide by 2. So the exact same process doesn't change because we're not solving for X. That gives us 10 equals 2L. We talked about this before, that's 2 times L. The opposite of multiplying by 2 is dividing by 2. Don't change the sign. We get L equals 5. Some of these formulas may look a little intimidating at first, but like I said, particularly if you got numbers to plug in, you're only solving for one variable. It's just like solving for X. All right, let's do 16. That one's a bit messy. It's messy looking anyway. So we have, where is it? Now we have A equals 1/2 little b plus capital B H, and we even have a decimal here. Again, if you have a decimal in the problem, that means we're going to be dealing with decimal answers, not fraction answers. I would almost guarantee it. Sometimes MyMathLab is weird, but that's why we're also talking about rounding to the nearest hundred. We have 1/2 little b plus capital B H. A is 5, little b 15, capital B 20. So here's what here's my thought process on this is, what do I know? What am I trying to find? Well, I know A, I know little b and capital B. What I'm trying to find is H. Our goal here is to get H equals. So let's plug in what we know. 8.5, 1/2 times 19 plus 20 times H. Which brings up the question, what do we do next? Well, there is numbers going on that right-hand side. So do inside parentheses first. And now what do you do? At this point, some students I think would divide by 30, both sides by 39, and then they would deal with that 1/2. I'm going to recommend continue doing this. We'll work that right-hand side as much as you can. Now, I'm not a big fan of mixing fractions and decimals, but one thing I will point out, because normally I would think of this as 39 halves h, and then I would invert multiply. I would flip that, make that 2 over 39, multiply both sides by 2 over 39. But because of that decimal, let's take everything to a decimal, which if they're going to give you something with fractions and decimals, those fractions should go to nice decimals. So this should not be a decimal that goes on forever. 39 divided by 2 is what? 19.5. Yeah, so 39 divided by 2 is 19.5. So normally, like you said, I'd rather have both of these as fractions, but the problem gave us decimals, so let's go to decimals. Does that make sense? I mean, or you could just, however you want to deal with this, that takes a little bit of practice. You could just, you could go in your calculator and do 58.5 divided by 39 halves. I'm just going to give you a decimal answer. But for the notes, this is kind of how I would handle it. Now we finally got that right-hand side as simplified as much as we can. So now we can divide both sides by 19.5. This is going to be a messy decimal number or a nice one. Oh, turns out that's 3. All right, this is where I was wondering, if this was going to be one of those long decimal numbers that goes on forever. That's why the instructions we're talking about rounding to the nearest hundredth. But it turns out it's a nice number. That's just 3. Okay, so it may have looked messy at the beginning, but once you plug the numbers in, then just kind of go step by step. And then there you get this. Like I said, that's a bit messy dealing with decimals and fractions. In the end, we just get a nice whole number of 3. So that is one type of formula you're definitely going to deal with. Is we're going to give you the formula, we're going to give you all the variables except one, and you have to solve for the remaining. What happens if we don't give you values? That's where the rest of these are coming from. So when it says solve for the indicated variable, that means you're going to have to, in your brain, think of the variables sort of like the variables you're not solving for, sort of like numbers, and the variable you're solving for, sort of like x. That hopefully that will help. And let's do this first. 18 is we're solving PV equals nRT for T. So here's why I asked what the goal was from the very beginning. And so what is the goal here? Well, we're solving for T. That means we want what? We want T equals something. Our whole goal is to get T by itself. And so if you understand that, what that tells you is the N and the R is what has to move. The P and the V is going to stay on the other side because it's not starting on the same side as the T. So there's power in slowing down and knowing what your goal is, like knowing where to go. If you don't know where you're going to go, it's sort of like jumping in a car and start driving, and like 30 minutes later, trying to figure out where you want to go. Now, I kind of like to figure out where I'm going first before I start driving. Right? And so how do we get T by itself? Well, what's the connection with the N, the R, and the T? Anytime you have variables next to each other, they're always multiplied. So the opposite of multiplying is dividing. What are you going to divide by? Well, you could do this in 2 steps, since there's 2 variables, but that's the messy version. So both of those are times T. So just divide both sides by NR. What's NR divided by NR? It's 1, just like 2 divided by 2 is 1. 8 divided by 8 is 1. NR divided by NR is 1. And guess what? We have T by itself, so we're done. Because over here, is there anything that can simplify? No, because we can't divide letters, and so it's not like we have numbers, or or we don't have a p divided by p that we can cancel out. Those are all different. There's your answer. If you're in chemistry, you're going to deal with that formula quite a bit when you're dealing with your gas laws. All right, how about 19? F equals 9/5 C plus 32. We're solving for C. Okay, so that means we need to get C by itself. So what has to move in this problem? Well, the 9/5 is going to have to move, and the 32. Which one do we deal with first? Well, that's 9/5 times C. And so we've talked about this. You always do your extract first, your multiplying dividing last. So deal with 32, and then we'll deal with the 9/5. So how do we move 32 over? Well, it's added. So we subtract it from both sides. What do we do with f minus 32? Absolutely nothing because those are unlike terms. So that left-hand side is f minus 32 equals 9/5 C. All right, so now how do we get C by itself? Well, we could divide both sides by 9/5. We talked about that being messy. This is where that invert and multiply really comes in handy. So instead of dividing by 9/5, I'm going to multiply both sides by 5/9. Okay. Now notice I said both sides. So we're taking that entire side times 5/9. The only reason we're doing this is 9 divided by 9 is 1, 5 divided by 5 is 1. We're left with just C. What do we do with this? Theoretically, you could distribute, but there's no need to. Pretty much once you get your variable by itself, you're pretty much done. Usually where people make mistakes on these a lot of times is after they get to this point, they start trying to do more and then get things that should not be. All right. And we've solved equations like that before, so it's just, we just had X in there. I really wish I could pause for questions here, but if I can't, let's just keep doing examples. And that's one reason why this first unit videos are a little bit longer than that might normally be. I think is because since I can't see what your questions are, I'm trying to do a few more examples than I normally would. All right, so here's number 20. AX minus B equals C. And they tell us A is not equal to 0, and we're solving for X. I'm going to come back to that A is not equal to 0. The real thing here is we're solving for X. So that means we need to get X by itself. So what has to move in this problem? The A and the B, because those are on the same side as the X. We're used to doing this with numbers, like it gave you like 7x minus 8 equals 3. This is the equivalent of what we're doing. Is just now, instead of having numbers, we're having everything as a button. Our goal is still to get X by itself. So what do we deal with first, the A or the B? Well, that's A times X, so we're going to deal with that last. So we're just dealing with B first. So opposite of subtracting B is adding B. That goes to 0. We have AX. So what do we do with C plus B? Nothing, because those are unlike terms. You could write that as B plus C if you wanted. They're both positive. Sometimes we go in alphabetical order, but I just had C on top, so I'm going to keep it as C plus B. Now what do we do? Well, that's A times X. So we're going to divide that side by A and that side by A. X equals C plus B over A. You have X by itself, so you can stop. Now, one thing I do want to point out is sometimes students want to simplify this, And once we start solving for y equals, this comes into play. If you want to simplify, try to rewrite this any other way, notice that this is the same as both of those on top being divided by a. Now think about how do you add fractions that have the same denominator? You add or subtract the top and then just keep the denominator the same. So something like this, that actually means both of them are divided by the denominator. You can't just do one divided by a. It's either both divided by a separately or keep it as one big fraction. Right, so this is sort of like the preferred answer. This would be totally acceptable. And here in a moment, we start talking about y equals. We actually want to do this. But then there'll be numbers. So we got to be a little bit more careful there. The other thing, why is a not equal to 0? Why did they put that in the problem? Well, look at our answer. Can we divide by 0? So if you try any number divided by 0, you're going to get an error because we can't divide by 0. 0 can be on the top, but we can't divide by 0. That's why they were putting that in there, because they knew at some point we're getting down to here. All right. So these are like I said, the earlier formulas, they all had like real life context. And they were geometry formulas. There's some chemistry formulas. But we also need some algebra formulas when we get to lines. I'm not going to do 21, but let's just talk through like the first step. So first solving a equals p parentheses 1 plus rt, which if you've done any accounting or finance, that's a simple interest. We're solving this for r. Sort of the problem here is that r is inside the parentheses. So what can you do? Well, most people will distribute the p, and then once you do that, then it's basically like the last problem we did. Or some people like to divide by p first and kind of go from there. If you want to see that, if it comes up in homework and you have any issues with it, let me know. That is, like most people there would distribute the p and make it a little bit more like what we just did there. All right. Let's get into, like I said, these are, when we get into unit 2, we're going to start with graphing lines. And so one of the things we're going to do with lines quite a bit is use this form y equals mx plus b. And that's what's called the slope-intercept form. And so it's going to be a very common skill that you need to be able to take something that looks like this and solve it for y equals. I want to do 23 first before 22 because there's no negatives, so it'll make it a little bit more straightforward. But we are going to back up and do 22 as well. So if you're looking at 23, if you're solving that for y equals, that means we need to get y by itself, everything else over to the other side. That means the 2x has to move and the 3 has to move. And that's 3 times y, so that's going to be dividing by 3. So again, that's the last thing. And how do we move that 2x over? That's plus 2x, so we're going to subtract 2x. So on the left-hand side, we do have 3y. Now, on the right-hand side, you could definitely say that as 2 minus 2x. But since we're talking about the slope-intercept form, we want the x term first. So get in the habit when you're solving for y equals of putting it basically in descending order with your polynomials, because we need the x's and then the constant. If you're going to do that, make sure you don't lose your signs. So that is a minus 2x and then plus 2. Definitely don't add or subtract those because they're unlike terms. Okay, so don't add or subtract unlike terms. All right, so we almost have y equals. We need to deal with that 3. It's 3 times y. We're going to divide by 3. Now, in that previous problem, where did my word go? When we had that ax. All right, now I've lost my word. Okay, on that previous problem, we divided everything by a, and then we stopped. All right, if we do that here, sorry, I can't find my word. We'll just go through it. That would not be wrong if you're just solving for y equals. The problem is, if we're solving for slope-intercept form, we really want the x term by itself so we can see the slope, the m, and we want the constant by itself so we can see the y-intercept. So like this, if it said up here where it said solve for y, I would actually accept this because it is solved for y. But if it says slope-intercept form, what we need to do is, instead of doing one big division, divide each of these terms separately by that number. So do minus 2x over 3 plus 2/3, 2 divided by 3, which we talked about this, the x being on top is the same as it being minus 2/3 x. So that would be the preferred way to write that answer. So if we're solving for y equals, don't divide everything by that, split it up and divide each term individually. And then, of course, it's those are fractions, so if they could have been simplified, you would need to. Like I said, this is a skill that you're going to use, definitely going to be using a fair amount in Unit 2. Again, I want to say other questions, but I can't hear you. So, all right, let's do number 22 says solve for y equals. So technically we could do it this way, but we need the practice of splitting it up. So let's solve it just like we were solving it for x plus b. Right, so what do we do first here? Well, to get y by itself, the 2x has to move. So we're going to add 2x to both sides. Now, when you do this, don't lose that negative with the 11. So that is negative 11y. And again, get in the habit of putting this in the mx plus b forms. Put the x first, the constant second. That is descending order for our polynomials. So we get minus 11y equals 2x plus 22. And then we've done this before. We're going to get y by itself. So we're going to divide both sides by negative 11. And remember, don't change the sign when you're dividing. And over on this side, divide both pieces by negative 11. Get y equals, and then 2 divided by negative 11 is negative 2/11 x. If you leave the x on top, MyMathLab should accept it, but get in the habit of putting the x up front because we always want that, for the slope, we want that number times x. And then we got plus 22 divided by negative 11, that's minus 2, the fraction. This is a skill we're going to practice. I remember at the beginning of the video I said like chapter 1 stuff is topics that we're going to see multiple times, like common themes throughout the semester. This is one of those things I'm talking about. This is solving linear equations. There's a very, and formulas, but this is a very specific formula that we're going to be using multiple times. All right, let's do one more, and then I'll jump into MyMathLab, see if there's anything I missed, and then we'll be good. All right, so solving for y. We're going to divide by 7, subtract 4, so we'll subtract 4 first. X minus 4 is nothing we can do with. Those are my terms, so we get x minus 4 equals 7y. Divide everything individually by 7. Now, x over 7 is the same as 1x or 7. So that will be 1/7 x minus 4/7 equals y. Good. That is solving linear equations. Let me jump into MyMathLab and see if there's anything else I want to cover. Here's definitely a messy version of this. I'm just gonna get you started on this. This is one, on that left-hand side, you got two distributions to do. So you gotta do the negative 4 times both of those. You gotta do the negative 2 times both of those. And then you're gonna have X terms to add, subtract. You're going to have constants to add or subtract before you can even start solving for X. And we did one that was not quite that messy. What number was that? And now I've got all these papers floating around everywhere. It's a bit messy on my desk. Yeah, this was sort of like, number 5 and number 8 on the handout. If you back up to those are like not as messy versions of this. So this is something that you definitely work up to. Did that exact problem. Oh, that was okay. Number 15. That would be showing on the screen, right? Yeah, let's do number 15 in the home. That's one advantage of watching these videos. I I look for things in the homework that trip people up. Sometimes I know ahead of time. Sometimes I don't remember every single example in there. So one reason at the end of these videos I always bring up MyMathLab. So this is number 15 in the homework. And this is capital. Let's see. So mechanics. So this is from like a physics class. So F equals little m v squared over r for r. Now on this one, it's definitely a bit messy, so I don't think this would be a good test question. Sometimes in the homework, I throw out what I call like stretch your muscle sort of questions. And so this one's a bit weird because what we're trying to solve for is in the denominator. So what do we do? Here's, I think, the key on this one. We have a fraction on this side, put that over 1. So now we have a fraction equals a fraction. So if you see that, now we have a proportion. And how do we solve proportions? What's the first step? Is the cross product. So for the cross product, now that this is a fraction over 1, multiply those and those. We have f times r equals 1 times m v squared. Now the question is, what next? Well, what are we trying to solve for? Trying to solve for r. So r has to be by itself. So what do we do with the f? Well, that's f times r. We just divide both sides by f. R equals mv squared over f. All right, so this is why, like I said, it's the same skill set we've been using, but like recognizing that this is a proportion because you can put that over 1. That's the kind of above and beyond of this problem. Because like once you do that, like I said, it's back to a cross product, and then the cross product gives us a pretty straightforward problem. But really, kind of getting that starting step, it can be a bit tricky. Like I said, I don't like putting stuff that's a bit tricky like that on the test. I've got enough proportions and other formulas I can throw at you to keep you honest. But sometimes, like I said, this is a stretch your muscle sort of problem. All right. Let's see. Bring back up what I'm sharing. So as I'm going through here, like number 16, A equals P plus PRT, give you capital P, we give you little r, we give you little t. So this one's nice because we give you everything on the right-hand side. You just need to know A, so all you got to do is plug it in and you'll get your answer. There's not even a solve on that one. But it can look intimidating until you just figure out what you know and don't know and go from there. This one's solving for y. This one's nice because it's plus y, so all you gotta do is subtract 2x from both sides, and bam, you're done. Something like this, we talked about this. You're going to subtract 2x from both sides, and you're going to divide everything by 9. Whether or not you need it like in one big fraction, or if you want to divide each one separately, this is where if you think you're doing it right, and you don't know if you got the answer written like MyMathLab wants, go to that example, which the vast majority of these problems do, and go all the way down to the end, and notice that well, they put it as a big fraction, and they went ahead and went on. They might well accept it as one big fraction, but I would say anytime you're solving for y equals, it's probably best to just go ahead and put it in y equals mx plus b form. If this was a test, since the instructions didn't say slope-intercept form, I would give you full credit. This is something I'll be more picky about in Unit 2. This first test, we're mainly solving for y equals. So right here, with that minus 2x plus 20 over 5, solve for y equals. Okay. But when in doubt, look at the examples, how the answers are in the examples in the homework. All right. Same sort of, this is like with these formulas, we've done these formulas before. It just looks different because with all these different letters. So let's do this one. This is 24. The homework. We'll solve. We have capital M. Oh, by the way, MyMathLab, you have to get your capital lowercase right. If you don't use the same capital case, lowercase and uppercase, you will get your stuff counted wrong. We're solving for T. All right, let's do this one. All right, so M equals Q plus QRT. We're solving for T. So we want to get T by itself. So how do we do that? Well, that Q has no T with it. This Q and R are with the T. And so this is where that is a multiply. That's Q times R. So you may want to put that in parentheses. And that Q is just added. What do we do? You get T by itself. So we're going to subtract Q from both sides. That goes to 0. So we have M minus Q equals QRT. We want to solve for T. So those are both times T. So divide both sides by that. That cancels out on that side. We have T equals. This is where I would say stop. Because, and we've talked about this actually kind of goes back to the R7, the rational expressions. You either stop here, or what you have to do is divide both sides, both of the things on the top, by the denominator. So it's either a whole thing divided by QR, or each one separately divided by QR. Right? Because that's a binomial. You can't break up a binomial and factor out part of it. It's either all or nothing. But the only way you can do it legally is do it this way, because now we're treating this like adding fraction to get to there. Now you can do Q divided by Q. That would be M over Q minus 1 over R, because there was nothing left. So that would be an equivalent answer, but but what you don't want to do, and I see this all the time, they want to divide those Q's out. And that's bad. It's either keep it as M minus Q, don't break it up, leave it all over QR, or you have to break it up and divide both of them by QR, but don't do something to it. This is where a lot of people get tripped up on the formulas. They try to simplify an answer and then end up simplifying incorrectly. Okay, so that's why I say for most of these formulas, once we're gonna, if it's y equals, we're gonna want to do this because it's all gonna be numbers and x's. But if we got a bunch of letters like this, don't there's no need to do the extra simplification. Stop there. All right, so I think that's good. Okay, so as always, if you have any questions, please email me. Don't forget that in the homework, there's the Ask My Instructor button, which will bring me a link directly to your homework problem. And as always, if you ever want to meet for tutoring, either in person or via Zoom, email me and we can set up a time for that. Have a good day, and we'll talk to you soon.